There it goes. And then after we do this one, we will take a look at number 1, you say? Okay, we'll do 1. We'll see how much we can get to before this thing shuts itself down. So first things first, this one had a whole bunch of questions. So you basically, the first bit, you had to just plug in numbers that were given to you and letters. So let's see, it says dV over dt, that's the rate at which the volume is changing with respect to time, blah, 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 blah. Here it is. Liquid flows out of the tank at a rate of 50 cubic inches per minute. At what? Okay. Okay, so I guess that's what's going on, is that the liquid is flowing out of the tank at 50 cubic inches per minute. You have a different number there than I do, but whatever it is, you're going to put that in here as negative 50, I hope. We're going to find out, because I'm just going to click the cheater button here. Look, I got it right. Okay, we need to determine what is it that they're asking for here. Just a minute. Blah, 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 blah. What is the rate the height of the liquid is falling when the height of the liquid, okay, so we want to know dH over dt. So that's the thing that we're looking for when the height is 40 or whatever number you have. So yeah, it's a little annoying that you have to kind of fill in the blanks here. Look, I got that one right. I got that one right. Very nice. Don't you wish you had the little key next to you could check? That's one of the nice things about someone asked me before class, do I miss the paper thing and having the big tome? You used to have to have this calculus book that was super heavy. It was like literally 5 kilograms. It was huge. And anyway, the back of the book, half the answers were in the back of the book. So you could go check and say, did I get it right? Yeah, I got it right. And then you'd flip back. Anyway, but yeah, those days are all gone. Okay, so let's see, going on, step 3, the volume of the cone, blah, blah. Okay, simplifying this fraction. Okay, basically they just want you to simplify this, I guess. What is 48 over 72? It's divided by what? Oh, look, it's 2/3. Okay. I was too lazy to do it in my head, but you could have done that yourselves on a calculator, just figure out common factors. And then R is going to be 2/3 times H, of course. You're just solving for R. I'm just double checking. There it is. Then they want you to substitute this into the expression up there. So what do we get here? We get 1/3 times 1/3 times pi times 2/3 H squared. I'm just going to write this in here. Literally, let's see if it likes me to do this. And then we've got 2/3 times H. And then I've got a square here, and then times H. Notice that I've literally just substituted this into that. That's all they want you to do there. They probably want me to simplify. Oh, they do. I don't think they're going to like me with this, but you could easily simplify that. I'll do it right now in my head. They're okay with this? Okay, well, it would be 4/27 pi h cubed. Let me see if they have that here. Yeah, 4/27 pi h cubed. Then you have to differentiate using the chain rule. Once again, that's the pretty easy stuff. So I'll just do that really quickly. 4/9, because you multiply by 3. I'm doing the derivative of h cubed. So you get 3, and I'm just going to cancel with the 27 if you don't mind. And then you've got h squared, but don't forget to put in the dH over dt. Oh no. Can I make this not do that? Maybe if I put a space. Ah, that's better. Let's see if it likes me. Syntax error? No syntax error. Okay, so we'll check. Look, it's right. Wait, oh, we're down to the last two, which someone said that's where you got stuck. So the first, the second to last one, you're just doing the derivative of whatever you have here. If you've got this one right, then you can you check like the intermediate steps, or do you, like if you submit, will it ding you if you do that? No, it won't ding you?
It allows you the same amount of tries for the remaining questions.
Okay, so you still have, you can still retain your tries. Good. I could always adjust that if you find, because I'm still new to this thing, even though we've been doing this for 2 months now, or a month and a half. This is still a new system to me, and I can change it to be 4 tries. So if you think 3 tries aren't enough, let me know. I need to know, because, I mean, next year's students will suffer if you don't help me improve things. So anyway, then finally you plug in the numbers, basically. and you're going to solve for this. Let's see, can I do that in my head? Where is, we got negative 50 for dv over dt, and h is 40. And so that means that you're going to have dh over dt is equal to negative 50, whoa, divided by, and then we have 4/9 times pi. I know this is kind of a cheater way of doing this, but I think times 40 squared. Is that going to like me? I don't know if it's going to like me to do that. Basically, I just plugged in negative 50 over here, 40 here, and then I said, well, just divide everything by this mess. Okay, let's find out. I know the answer that they're going to give is different from mine, but I'm kind of curious to see if they, oh, they're not letting me. Oh, I had my mouse on the wrong screen. So let's see if it likes my answers. I got it. Oh, it liked it, even though it's totally garbage. I mean, you do that for your algebra teacher in high school, and they're going to say, yeah, that's not right. So does that look good? What?
Could you scroll up a bit so I can see step 3?
Absolutely. Let's do this. Scroll it up. Step 3. Why is step 3 so long? Okay.
I just need to see the change between the last part.
And here, I'll even click this little key here. Yeah, by the way, no one's been using the message system through, is it not enabled or something? I wonder if I've disabled it. Because no one's been messaging me through Lumen. But if you message, I've got a couple of you like to take photos and text me with them. And like, well, okay, I'll try my best. Anyway, if you message me through Lumen, I'll get the key, I'll get this for your, even though you can't see it, I can see it, and then I can maybe give you a hint, like, yeah, you just left off the 4, or I don't know what you would have left off. But like here, you might easily just write this as 2/3 times h squared instead of 2/3 h quantity squared. I don't know. Just so you know. Yeah, let me know. You can always email me if you don't have the message your instructor link or something and say, hey, this isn't working. It should be there. I should check the settings. Maybe if I remember. Anything else from this one? We've done the best we can with that one. Now, someone complained about the first. Oh, you have a question?
Yeah, it's not on that file, but
it's on number 1?
Yeah.
Yeah, let's go back to number 1 then. Excellent. That's the next thing to do, is go back up here, all the way up to number 1. So let's deal with this one. We did one very similar to this last time. It'll just take me a minute. This one doesn't have the, I kind of like the step-by-step where it walks you through, but I know it's frustrating for you because then you're like, well, if I can't get step 2, then I can't even go on to step 3. But let's go ahead and do this one. X is equal to whatever. This is my set of numbers. You're going to have a slightly different function, but it'll be close enough. It says that the company, let's see, has increased the price. So dP over dt, the increase in price is $5 per month. And we want to know what is happening when you're selling, the price is 220. We want to know the change, the revenue, the change in revenue. So what is dr over dt? Okay, I'll show you what I've written, my mess. It's pretty messy here, but there is all of the mess that I've written. So just to recap, you have this price function up in the upper, oh, no, is this going to be dumb? Okay, there it is. Price function in the upper left. So the number of widgets you sell is related to the price via that function. We know that the price has been increasing this much per month. Currently, the price per widget is $220. Why be widgets? This could be unicycles. So it could be the price of a unicycle, which seems appropriate if it's a reasonable unicycle. And we want to know the change in revenue with respect to time at that moment. So just remember that revenue is equal to price times X. So price times the number of things you sell, basically. So we could write this like this. So I know we think of, or at least I've, presented revenue as a function of X, but in this context, we're going to write it as a function of P. So hopefully you got something like that. You've got the price times the number that you're selling, and I got the number you're selling from the price function there, or the demand function, sorry. Now I just have to write this slightly differently. And then we're going to have to use the quotient rule and the chain rule. For those who don't like the quotient rule, I'll show you another way that you have an option. So notice what I've done there. Oh, come on. Okay, sorry. Just like, it's frustrating to me that the technology, why? I think, well, I changed the resolution. I think maybe that was my problem, is I wanted it to be high res. Maybe I should go back to the lower resolution. Just a minute. Set this. I thought, hey, might as well go all the way. Let's see. There, I changed it back. Okay. Anyway, getting back to this. So now we just have to do the derivative. So let me use the product rule instead of the quotient rule because that's less work in my mind. There. We'll do it this way. It's the same function. So then dr over dt. Using the product rule, here is my f, here is my g. So I'll talk through this. So we do f prime times g, leave g alone, plus f, I'll label these in a minute. Here, let me label them now. There we go. We got f prime, and this is g, and this is going to be f, and this will be g prime. And to do g prime, I'm going to have to use the chain rule. But I think we're good enough. Oh, come on. Still being dumb? There we go. Yeah, let me know if there's some optimal place I can put this. Yeah? Yeah?
For f prime, does it need to have dp over dt?
Yes! Thank you. I almost, rookie mistake. You saved me. dp over dt. I was lazy. I'm going to repent of my laziness now, and I'm going to do it right. I'm going to do it over here. Let's make sure. Let's do this. F is 20,000 P. That means F prime is 20,000 dP over dt. Thank you. So over here, I'll just put the sort of the sketch. I'm probably not going to have room now. That's okay. And then G is going to be this thing. And then G prime is negative 1/2 times 5p plus 1 to the negative 3/2 times 5 dp over dt. So it's all scrunched there. Okay, so now that's the chain rule right there. I just did the power rule here. Multiply by the power, subtract 1 from the power, and then leave the thing in the parentheses alone, and then you do the derivative of what's inside here, and the derivative of what's inside there is 5 dp over dt. Thank you, Elena, to remind me about the dp over dt. Whew. Okay, so getting back here, let's see if I can cram this all in. Negative 1/2 times 5p plus 1, negative 3/2 times 5 dp over dt. Does that look all right? It's kind of a mess. Yes, what do you think? It timed out? That makes me so angry. It should know. It should know that I want to keep going. Here, just a sec. Exit, fix, just a sec. Where is it? Going down here. Max on minna, linear approximations. There it is. Watch this. Settings. Modify. Page. There. That will get us where we need to go. Now it's not timing out. Refresh your screen. It will be there still. Do I need to make these assignments due at 9? Maybe I do. Okay, we're almost done though. We're so close. Now I just have to plug in the numbers. So the numbers I'm going to plug in are dp over dt is 5 and p is 220. Let's see if I can do that. So dr over dt is equal to 20,000. dp over dt was 5 and this was 220. So P is 220. P is 220. So do 5 times 220. You do your own number. 5 times 220 is 1,100 plus 1. So 1,101. I'm just don't want to have to write down 5 times 220 a bunch of times. So then this stuff times 220 times 1/2 times 1. Now I'm panicking because time has run out. 1101 to the negative 3/2 times 5 times 5. There. I've plugged it in. You can calculate that, or you probably could just type all that mess in and it would be correct. So I refuse to go any further. So it might be easier to simplify. Actually, I'll do one more thing. Sorry. Notice that 20,000 times 5 is 100,000, and you have 20,000 times 5 over here as well. So I'm going to write it like this. 100,000 times 1101 to the negative 1/2. I'm sure there's other simplifications I could do. 5 times 220 is 1,100 over 2. I guess that's going to be a negative times 1101 to the negative 3/2. Okay, there. That's as far as I'm going to go. But you could, I mean, I could probably simplify further. I definitely could. What? I think I got them. I got this 5 times the 20,000 is this, and then this 5 times 220 is this. So I think I got them all. But yeah, you do what you do. You type all this stuff in. I would probably actually simplify it further before typing it in because I don't like to type, but I can write. But I'm done. I refuse to go further. Well, that's your problem. Okay, what are your numbers?
Come on. 80,000 over 60 plus 1, and then price increases by $5 a month, and it's all 250.
Wait, and 6p? What's the bottom of that fraction?
6p plus 1.
Okay, let's go down here and just change everything. So down here at the end, we would have 50,000. This would be 6. This is going to be 50,000. This is going to be 6. This will be 6. And then at the answer, you should have 50,000 times 6. No. dp over dt you said was 5? Is dp over dt still 5?
Yeah.
Okay, so that's still 5. And then this number will be different. Give me a sec here. 250. 250 times 6. Come on. That's 1,500. So 1,501. So this is what you should have. This will be 50,000, 250, 1,501, and there's a 6 here instead of a 5 somewhere. I don't know. One of those 5s becomes a 6. This is not the same now. There. Is that what you had? Okay. And then message me if it's still wrong and I can pull up the actual answer. Are there any other issues with this homework before I lose my mind? Sorry. All right, if not, the quiz is like number 2, I think. Number 2 was easy, wasn't it? Was that the one that was easy? Thank God. This one will be good then. So we all need some encouragement, don't we? So let's do number 2, or do the quiz when you're done typing. I'm so curious. Yeah. I hope. There you are, Joy. Here you go, one more for you. Do that out.
That times 6 times 5 or times 6 times 6?
It's 6 times 5.
Okay.
6 times 5.
Okay.
Get all your parentheses, and then message me if it's wrong. Is there a message me button?
Yeah.
Good. Did you already?
I am right now.
Because you got it wrong?
Yeah.
Awesome. And then do the quiz. I'll look at it while you're doing the quiz. I need to get the quiz, though, up on the screen for the people who are watching from home. Give me a sec. Good. That's good. Pardon me. Oh. Oh. Let's see. Okay. All right. Phew. I have figured out his problem. Hopefully you figured out my problem, and we'll collect what you have if you're still working. Hopefully you can finish up soon. This wasn't too painful, was it? Excellent. So far, so good. All right, I'm not rushing you, am I? All right, good. Put your finishing touches on. Very good. Okay, so we'll do this really quickly. I didn't get to do it. We'll go back to the problem from the homework in just a minute, but I do want to get this one done. Let's see. There. Oh, sorry. I just want to make sure I can. There. It is recording. It is good. Okay. So of course we're doing profit. It's going to be revenue. Whoops. So 90x minus 0.5x is the revenue minus the cost. And don't forget to subtract off the whole cost. I probably should have put that in parentheses to emphasize you're subtracting off 20x plus 5, but then the plus becomes a minus when you distribute the negative. So there's the profit, dp over dt. I suppose I could simplify this a little bit. Minus 0.5x squared minus 5. So dp over dt is going to be 70 dx over dt minus, I guess, just x, because the derivative of 0.5x squared is just x, dx over dt. And then the derivative of 5 is 0, so we're all done now. Now just plug and chug. We have x and dx over dt there. So 70 times 50 minus 50 times, oh, I blew it already. Got it wrong. That should be 10. So 70 times, come on, times 10, and then 50 times 10. All right. So 700 minus 500 is 200. Okay, I think I got it right there. Good. Okay, so the Ethan's problem is a comedy of errors, and he is partly to blame, and I'm partly to blame. So notice up here, 80,000. 80. I wrote it down. He said 80,000. I wrote down 80,000. But down here, what am I writing? Where'd that 50,000 come from? I have no idea. It should be 80,000. So that's part one in the problem. So we need to change that to 80,000. Don't do it, Ethan. Don't worry. And then, sorry, but this is somewhat of a FERPA violation, but I don't care at this point. It's too much fun. So the other problems, notice this is more of a typing error for Ethan. This isn't my fault. This should be 50,000, or actually 80,000. And then this should be 1501. So you just didn't type it. You were typing too quickly. I was rushing you. So anyway, I did do this with the 80,000 on my calculator. I got it right. Look at this. I can actually give you full credit for this. You don't have to do anything. Yeah, if anyone else has problems like this, I believe it now. If you refresh, it'll say that you got it right, or at least that you got full credit. Maybe not that you got it right. So this is the sort of power I have over your homework. And if you come and meet with me and sit down with me and do your homework with me, like tomorrow, for example, and you get something wrong, I might just do that for you too. Because, you know, we have suffered enough together now that we don't need to do that more. All right, anything else? No, we don't need to talk about the homework. Please don't ask any more questions about the homework. Did I get all the quizzes? Where did I put them? Well, they're somewhere, I'm sure. Oh, they're there. I usually like to staple them together so that they stay together. Okay. So Valentine's Day. Since it's Valentine's Day, I do have this to show you. Where is it? Valentine's. There it is. So I bought a big bag of these hearts here that you can, if you want some, feel free to take them. And I put a little scoop in here so that if you are worried about passing along germs, you can sort of scoop a few out. The serving size is 5, but if you need more than 5, but anyway, you can pass that around. But I was looking through because I'm always curious to see if we have any mathematical hearts, and I found a few. But first, the normal ones. This is the sort of thing that I'm used to. You know, love, forever, cool, I love you, sweet. You know, those are all normal that I remember from when I was a kid. There's some new ones that I don't remember when I was a kid. I don't understand all of these. I was hoping you could help me out. Bay, what does that mean? BFFL? I'm guessing.
It's
What?
like short for baby.
Bay? What? That you shorten it by removing two letters and adding one? That makes no sense. BFFL, best friend for life. Is that what that is? Okay, whatever. And then I think that says DM me. I think that's what it is. So we're supposed to direct message me, and then goat. I think I know what that means. LOL, I know, but this one, limey, limey, isn't that like a bad word when you're talking about like a Irish person or something, or is it a Italian? A limey. I think it's Irish. Anyway, what is limey? Oh, is that what that is? Is that really something that people write? That's really pitiful. Okay, good. Thank you for that. I found this. This was cute. You have the bride and the groom. Very nice. Um, Yaz. Yaz. Uh, what? Yas? Okay, that's supposed to be something that you're positive about, right? Soup's cute. What in the world? And totes. Totes. I have no idea. When I think of totes, I think of those big containers that you put stuff in your basement. What in the world is totes? Oh, okay. See, I'm learning. Okay, well, let's see. There's I did find a few mathematical ones. There's be true. So being true or false is a mathematical concept that we're interested in. I like this one. You have the variables x times o times x times o. Would that be x cubed times o cubed? I was intrigued by this. They changed the s to a z. So you got hugs for reals and goals. And then I was overjoyed to find another one with a z on it, and it was maths. So we had that. And then digging through a little bit further, I found this one, Cutie Pie. There was this one, Forever. But then I found this, and I assume that these are in the same sort of vein here. Then we have this one, Study With Me. That's a good one for, this is how I met my wife, is I studied with her in college. Mu plus 3 standard deviations. I guess that means that you're, 3 standard deviations beyond the mean. This seems a little suggestive. Let's integrate. Take me to the limit, and then the integral from 0 to 1 of 2x dx, which you'll have to learn about later this semester. Now, I should confess that last night I'm lying in bed reading next to my wife. It's like, bedtime, 8:30 or something. And she says, hey, this guy was in lab. She does labs, does stuff. She was making plates. And she says, this guy rolled over and said, I heard about your Valentine's cards. And the guy's right there anyway. And he's like, and she says, and he said, he's looking forward to seeing what you get tomorrow or something like that. And I was like, oh no, I gave up. I was trying to think of something with like plates, because she pours plates of agar or something and does makes bacterial cultures. And I just couldn't think of a good joke or something funny. I thought of stuff this morning, but it's too late this morning. But this morning I didn't give up hope, because after sorting through all of this stuff this morning, I realized I could just take all of these hearts and put them together. And so that's what I did. I made this and glued it. You can see the hot glue here. I just glued all this onto construction paper. And so we have bridegroom goals. Yas. You're awesome. You rock. And then it goes on. Here we go. I love you forever for reals. Text me. XOXOXO. There it is. So that's what I did. I know that was lazy, but I just couldn't come up with something better than that. Over the past week, and maybe next year I'll do better. So what are we doing today? We need to do differentials. This won't take too long, hopefully, since I just wasted a bunch of time. I do have something that I usually do on Ash Wednesday, but that's going to have to wait because Ash Wednesday and Valentine's Day happen to coincide. So anyway, differentials. This is just a way of, and you'll notice that the homework is broken up into 2 sections. So hopefully that will help us as well. So we don't have to get too far. Differentials are a way of thinking about the tangent line as a tool to make approximations. Oh, here, I'll just give you a quick example. Let's say that I asked you, what is the square root of, let me pick a nice easy number. How about the square root of 81? What is the square root of 81? Do you all know what the square root of 81 is? It's 9, right? Okay, you all knew that though. You just didn't want to say it in unison because that seems a little bit weird. So 81, square root of 81 is 9. What about the square root of 82? Now, square root of 82, you know it's probably going to be a little bit more than 9, but exactly how much more than 9 is it? That's the question. So that's what differentials is going to help us do. It's going to help us sort of use the tangent line as a way of approximating calculations that we don't want to actually have to do. And you might say, well, I've got a calculator for this. Yes, you do. But how does the calculator know the square root of 82? And I'll tell you right now that the calculator does calculus to do the square root of 82. So it doesn't have it memorized. It does some calculus. So anyway, that's what we're going to be learning about now is the calculus that the calculator does. So the tangent line to the curve at a point is this. It's not all that complicated. So just to orient you, you might say, well, what is that? You've learned about this already. This derivative is the slope. So maybe I should write that down over here. Slope is equal to f prime of x, and I want the slope at this point. So that's why it's f prime of a. And then the rest of this, you might say, well, wait a minute. How do I know that that's the correct tangent line? Well, I'd used the point slope formula. Y minus y1 is equal to mx minus x1. And you'll notice that I've got everything over here that's over here. Specifically, you have the y right there. Minus the y1, well, f of a is y1, but I've moved it over. And when I moved it over, it became positive. And then you've got on the other side, m times x minus x1. So there it is. That's the slope, the tangent line formula. So because that is, because that's so easy to write, we're going to simplify or abbreviate the way that we rewrite that. But here's how we're going to use this to figure out what the square root of 82 is. We know that when x is close to, and I've got that in quotes, when it's close to a, f of x will be close to the tangent line. Just to illustrate this, I've got two pictures for you. Here is the tangent line to this cubic function, which you can't see because it's green. Sorry, I got to remember green is a bad color on this projector. But there it is, tangent line. Notice that if you're far away, those two are nowhere near one another. But if you're pretty close, like right here, the tangent line is pretty close to the actual function. In fact, I'll zoom in. Come on, buddy. There we go. I'll zoom in to just this little tiny region where they're almost touching. And you'll see that between negative 2.1 and negative 1.9, that tangent line is basically the same. I know there is a little bit of a difference, but it's not a huge difference. And it's not so big of a difference that it's going to make much of a difference. It might make a big difference to some people, but for us, we're just going to use that as an approximation. So how does this work? Well, we're going to use this tangent line, and we're just going to relabel it. So here's the way I'm going to label it now, is we're going to call it L of x, the linear approximation, tangent line approximation. It's just the tangent line. When you see this on your homework, you're going to see L of x, just tangent line. That's all it is. If you don't want to use the formula, you don't have to. It's just the tangent line. Let's actually do this for that problem that I had just a minute ago. I want to use f of x is equal to the square root of x. And I want to approximate, I'll put it down here, f of 82. I guess I should use the approximation symbol down there. Let's get rid of that and change it to this. It's approximately. So that's my goal. That's where I'm going to go with this. So I need the linear approximation. I need the linear L of x for this function. And what I'm going to do is I'm going to use f of 81 plus f prime of 81 times x minus 81. And the reason why I'm using 81 for my linear approximation is because I know the square root of 81. You know the square root of 81 because in my fantasy, you would have just in unison said 9 when I asked you what the square root of 81 is. It's early, I know. The sun is shining though. All will be well. So let's go ahead and do this. I need f prime of x, I guess. And I know you can all do this, and so this will give me a chance. Go ahead and jot down f prime of x, I guess, here, just a sec. Switch, 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 get over here, pick me. There we go. Everyone's excited. So Elena, though, gets to do it. What is f prime of x?
It'd be 1 over 2 multiplied by the square root of x.
Ooh, that's fancy. Now, if you're not as familiar with the square root of x as Elena is, you might have preferred to write this like this. This is x to the 1/2 power. And then you would have gotten this. It's the same thing. So those are the same. I like Elena's method, though. It looks so much cleaner than this negative exponent, doesn't it? So, but you can go either way. And, you know how it is with Lumen. They don't seem to care if you don't simplify. Okay, so let's actually do this. What I'm here, I'll first of all write L of x using this. So f of 81, you told me, was 9. F prime of 81 is going to be what I get when I plug 81 into that. So that's going to be 1 over 2 times the square root of 81, which is 1 over this 2 times 9. And then I've got x minus 81. How's that look? So far, so good? And now let's use this as an approximation. So f of 82 is going to be approximately the same as L of 82, which is 9 plus 1 over 18 times 82 minus 81, which is equal to, wait, can I do this in my head? 9.0505. Let me see, is that right? Let me try this. Oh, no, I'm off. It's a little bit too, I see. Yes, my mental arithmetic was off. That's fine. 5556. How's that? 9.05556. Just throw a 6 somewhere. Let's actually see what the calculator thinks the square root of 82 is, just for fun. 82, whoops, sorry, come on, clear. Square root of 82, 9.0554. So the actual thing, so I got 9.0555. The calculator gives me 9.0554. I know I'm rounding there, but I just wanted to brag about how close I am. So I'm close. Let's see, this is the tenths, hundredths, thousandths. I'm off with the 10,000ths place. So I'm within, I guess, technically two 10,000ths because of that and because I did round this. But I'm within 2 10,000ths of the truth using this linear approximation, which is a lot easier than trying to extract a square root when you don't know what it is. So that's the idea behind the tangent line using the linear approximation. Take a minute, look that over, see if anything doesn't make sense, because we're going to move on to the next problem. Yeah, what do you think, Elena?
Just curious, but it's not a coincidence that 82 is between the square root of 81 and the square root of 100, and square root of 81 is 9, which is the first number, and then it's 18 away from the square root of 100. It's 1 over 18. Is that?
That's a coincidence.
Okay.
Yeah, because but that's fascinating observation. Here's if I wanted to do the same thing for the square root of 83, the square root of 83, of course, is going to be a worse approximation, but I would do 9 plus 1 over 18. I'd still have the 1 over 18 is the derivative evaluated at 81. So it's 1 over 18 times 83 minus 81, which is, I'm kind of curious. So, that's going to be 9.
That would make it 2 18ths.
Yeah, 2 18ths. Yeah. Okay. So there is that. That's not coincidental that you're incrementing this by how far you are away from the one that you know about. But the 18 there. Sorry, I got to think about this for a minute. I think the 18 is coincidental. Okay. Look, see, these are mathematical questions. I mean, that's a beautiful question. Now I have to investigate because I'm a mathematician. Let me just see. So what if we were going to do, based on the square root of 100, we were going to try to find, so use this to approximate the square root of 102, let's just say. So give me a sec. This won't take long. So f of x is the square root of x. F prime of x is the same, 1 over 2 square root of x. And so then my linear approximation formula would be the square root of 100 plus 1 over 20, because it's 2 times the square root of 100.
And 121 would be the next one. So.
X minus... That's just trying to think, will this always be the case? Sorry, this is, I mean, it's a beautiful question. 121, you're right. Is that always going to be the case? Let's see, if I do, let's say I do, so basically, sorry, this is getting far afield, but it's so beautiful, I can't let it go. If we do x squared, and we compare x squared, which is, this is 10 squared, with the next square, I guess we're going to have to subtract, so let me get rid of this. Yeah, so just bear with me for a sec. So it'll be x, oh, yes, it is not a coincidence. It's beautiful. You do this, you get x squared plus 2x plus 1 minus x squared. That's 2x plus 1. The difference between a square and the next square is always 2 times x plus 1. Yes, you are correct. Not coincidence. Beautiful. Okay, but we need to get to what everyone else cares about. But thank you for that little nugget. I always love doing real math because the rest of this... Oh, it's real math, sorry. I shouldn't... Because I remember those fun days in grad school where I was just doing, I don't know, stuff like, well, like that. Okay, let's get rid of this and do another problem. So it's all gone. Let's see, oh, I've already got this one. That's boring. Do I have another problem? I hope so. This one's a good one. Find a linear approximation of sine of x at pi over 4. So we're going to do the same thing. Let me write down the linear approximation formula. L of x is equal to f of x plus f prime of x, x0 times x minus x0. So you're going to need to know the derivative. That's going to be f. We need f prime. And then we're going to have to plug in pi over 4. Take a minute, see if you can do that. And then we're going to use that to find, approximate sine of 1. Let's just do that. Oh, I didn't leave myself room. But at the bottom, that's what we're going to approximate. We're going to approximate sine of 1 using this linear approximation. So sine of 1 is approximately L of 1, which is equal to, and you'll tell me. So take a minute, you can do this. Okay. This is going to blank out for just a sec. I need to move this over. Okay. Good. Okay, it's going to blank out one more time. I just want to have this set up for when we need it. Okay. All right, let's do this. Okay, we'll step through this and make sure we get it right. First thing we need to do is we need to know the derivative of sine of x. Zach, what is the derivative of sine of x? It is cosine of x. Very good. And then what we're going to do is we're going to plug this number into each of these. So I need to know what, so L of x is going to be sine of pi over 4 plus cosine of pi over 4 times x minus pi over 4. But I need to know what the sine and the cosine are of pi over 4. Caitlin, do you know what the sine of pi over 4 is? Your calculator does, though, doesn't it? I'm sure it does. Oh, that's you're in degrees, not radians. Yeah, change it to radians. 0.707. That sounds familiar. You know what? I think that's radical 2 over 2. Yeah, it is radical 2 over 2. Yeah. But anyway, yeah, just to remind you, you can do your hand thing here. The sine is going to be the number of fingers down here, square root of 2 over 2. So here's 0, pi over 6, pi over 4, pi over 3, pi over 2. So square root of 2 over 2, this is going to be cosine. So now that we got that out of the way, Bryce, do you know what the cosine of pi over 2 is? Pi over 4 is? It is the same thing. It's radical 2 over 2. Pi over 4 is special for that reason. Now we can actually plug in 1. So you get square root of 2 over 2 plus square root of 2 over 2 times 1 minus pi over 4. Now at this stage, I'm going to cheat. I mean, technically, oh, wait a minute. What do we have here? We can combine those. Radical 2 over 2 times 2 minus pi over 4. Yeah, it doesn't really help us that much, but I'm going to do it anyway. So now I'll use my calculator, which is sort of cheating because how does the calculator know what square root of 2 is? It's using calculus. Well, it's a little bit more, it is using calculus. It's just not doing a linear approximation. There's another type of calculus it does, but I'm not going to tell you about that today. You'd have to take Calc 2 to learn that. But I'm going to just type this all in. So I've got square root of 2 over 2 times 2 minus pi over 4. And how does it know what pi is? I'll bet you can guess. Calculus. But anyway, this is equal to 0.85. Sorry, my 8 is terrible. 8588. And now let's actually do the sine of 1. Make sure I'm in radians. I am. And the sine of 1 radian is 0.841. So that one's not as good of an approximation. So the actual number is 0.8. I'm surprised that it's that far off. How far away am I? Just a minute. What is pi over 4? Ah, that's my problem. Pi over 4 is 0.78. So I've moved pretty far away. So essentially what's happened here is I've got my graph of my sine. Here's pi over 4. Here's 1. And so my linear approximation is further away from the truth than I would like it to be, but you know, you take what you get. It's still pretty close, isn't it? 0.8588. All right, so the final thing we need to do is to just make sure that you know this definition that we're going to be using on Friday. And oh, get rid of all that. And that's the idea of a differential. A differential is basically just like a derivative, only we're not going to commit ourselves to what we're doing the derivative with respect to, I guess, but you don't need to know that. All you have to do is think of it this way, that how far are we changing? So dy is the change in y, dx is the change in x. So how far is y changing with respect to x is basically what a differential does for us. And just to compare this with delta y is the actual difference. So dy is sort of my predicted, how much am I going to predict that y is going to change with respect to x, and delta y is the actual change. So the way that this is going to work is we're going to be given a function or something like this, y equals 3 tangent of x. And we're supposed to find dy, the differential. We'll be using this differential on Friday, but on your homework, you're basically just computing the differential. So the dy here would be 3 times the derivative, secant squared, times dx. Another way of thinking of this is you just have dy over dx is equal to 3 secant squared of x, and then you're just going to do a little bit of algebra to get up there. Basically multiply both sides by dx, which really isn't algebra, it's actually calculus, but we don't need to get into that. Okay, so let's take a peek at the homework so that you don't get scared, because there's some weird stuff here. So first off, up at the top, we have some stuff that you're familiar with. We've already done this sort of thing using the, oh, why is that showing? Using the tangent line to approximate the square root of 64.4, because you know the square root of 64, I hope. Square root of 64 is 8, just in case, just in case. Anyway, so that we've already done something like this. And then here, this is a little bit weird because they just give you f of x and f prime of x. So you're just going to set up your linear approximation using those. You don't have the function itself, it's okay. You have the function and its derivative. You can come up with the linear approximation. That shouldn't be bad. Here's the dy thing that I wanted to show you. So here you're just going to do the derivative of that and multiply it by dx, and you'll be fine. And then there's a couple of problems that involve some graphing. They want you to graph the tangent line. And so what that means is that you're going to actually have to like put points on this graph and graph a tangent line. I don't know if that's the actual, it's probably going to be this. I don't know what the actual tangent line is, but notice how the tangent line is very close to the actual curve. And then they have a question about that tangent line, I think. Down here, same thing. And they're going to ask you about delta y and dy, just so that you know, delta y, delta y is how far off you are. Dy, you would actually compute using the function. So do your best on that, but don't be scared of the graphs. They will be, they'll be okay, hopefully. So I think that's, yeah, the delta and the dy here should be fine. So yeah, do your best with those, and we'll pick up the pieces on Friday. You get the day off tomorrow, so you'll have plenty of time to do this. Feel free to message me. I'll see if I've got the settings proper to be able to message. That might be my issue. Open.